Hello and welcome to the Data Cloud podcast. Today's episode features an interview with Alex Izydorczyk, founder at Cybersyn. In this episode, Alex shares his vision of how integrated data can help to power better decision and policymaking, the need for better branding of alternative data, and how Cybersyn is focused on building out data as a service offerings across all industries. So please enjoy this interview between Alex Izydorczyk and your host, Steve Ham. Do you want to learn how the Snowflake Data Cloud can take your company and your career to new frontiers? From August 3rd to October 30th, the Data Cloud World Tour is making 26 stops around the globe to share how to use and collaborate with data in unimaginable ways. Hear from fellow data, tech, and business leaders, and get the latest on generative AI and innovations at Snowflake at an event near you. Learn more and register at snowflake.com/data-cloud-world-tour.
Alex, it's great to have you on the podcast today.
Great to be here.
Yeah. Now, you're the CEO of Cybersyn, and it's just over a year old, I understand. Tell us why you started it and what it does.
Yeah, good place to start. Well, we just crossed our birthday, so we are, in fact, exactly 1 year old as of a few days ago. Cybersyn, at the core, what we do is we sell data. We buy and collect data sets, and we monetize them on the Snowflake marketplace. I spent the first 6.5 years of my career at a hedge fund investment firm called Coatue. And there I sort of had a front row seat to what data can do to transform the way a business makes decisions. And especially throughout the pandemic, the timeliness of data was critical. And so, the motivation behind Cybersyn, behind starting Cybersyn, was very much to say, okay, there's so many other areas in the economy where better data would make for better decision-making, better policy-making, that I felt it was a mission worth pursuing beyond just a hedge fund.
Yeah. And did you start it basically by yourself, or did you have a couple partners to get going?
By myself. So I had, and the story's kind of interesting, I had a unique front row seat to the Snowflake Data Cloud story because at Coatue we were investors. We were customers, but we were also investors in Snowflake before the IPO. So I had a chance to get to know Frank and Mike and Christian and some of the executive team with an investor and a customer hat on. And so when I left Coatue, I sort of was back in touch with them, and one thing led to another, and Cybersyn was born.
Yeah, very good. Very good. It's almost like they're your partners, your founding partners.
It's interesting. It's a little bit like co-founding a business with an existing big business. So when people ask me, who's your co-founder, I say Snowflake.
Yeah, that's very smart. Now, I want to go back in history a little bit. You mentioned it, but so you got a BS in economics at Wharton School. You had an internship at Coatue.
Right. And
then they hired you. And you quickly became the company's head of data science. So what was the revelation that led you to work for Coatue? And what was Coatue leadership's revelation that led them to put a guy who was still in his early 20s in charge of data science?
Sure. So I think one theme throughout my life has been sort of focusing on interdisciplinary areas. It's unless you're the best 0.1% at something, it's very hard to win because there's probably many, many other people who are better than you at that thing. And I think that can be said of computer science. I think that could be said in business. I think that could be said of a lot of areas. And so, one clever hack I just noticed was if you focus on two things at once, you might not be the best programmer or sort of the best investor, but you're probably among the 0.1% that is that good at both those things. And so in college and at Wharton, I focused on economics and I was in the Wharton Business School, but I knew how to code. So I definitely wasn't the best programmer among the engineering students, but I was probably among the best programmers in the Wharton student group, right? And similarly, I probably knew more about investing in business than anybody in the engineering school. And so it was a little bit cross-disciplinary in that respect. And when I pursued, and I was lucky in the sense that Wharton had the statistics department in the business school. So you could sort of concentrate on something very quantitative while still being in the business school. And Coatue was a little bit of the same story when I was looking for internships in junior year, sort of as one does. There was a lot of opportunity to go to a quant fund, right? But I felt that there's a lot of people who basically had that skill set. And so it would be sort of being a cog in the machine. And at the same time, a lot of my classmates were going to traditional finance roles that would ultimately lead to investing or buy-side hedge fund-like roles in 2 to 4 years. But again, there's a lot of those people and they all had kind of similar skill sets. And so Coatue was a little bit of an opportunity to do something different. Traditionally, hedge funds don't hire right out of undergrad. Coatue was willing to do so, but only for somebody that could sort of do something a little bit different. And that different thing was programming, but it was specifically around web scraping and sort of gathering data sources to do proprietary research.
Right.
Why Coatue? I mean, I was just a little bit lucky. I think I was introduced to the right person. And then after I was introduced, it was just obvious they were the right firm in the sense that they were interested in novel forms of research. They sort of weren't doing it yet. So there was a lot of greenfield. And they were a technology investment firm. So they were sort of motivated, I think, to be good at using technology themselves to invest.
Yeah, yeah. Now, what did they see in you? You must know this.
I think, well, I think it's a good question for them. I think, from my vantage point, I think, first of all, Coatue has a history of betting on young people. Right. So when you look at the senior partners, the most senior ranks of Coatue, almost everybody there sort of grew up there in some sense. That is, maybe they'd worked at one other place before, or maybe not. Maybe they sort of, like me, came there relatively quickly. But I think they have a track record, especially in their senior ranks, of betting on young people. So it's not, for them, I think that's par for the course. I think the other aspect was I was one of those people that, knew enough to not sound like a complete idiot in sort of their area of expertise in investing. But then I knew a lot about sort of connecting the dots in data science and engineering on how data science and engineering could translate into their area. And the particular field we were working on, which was incorporating alternative data into the investing process, that field was pretty new. There was really no such thing as somebody who had 20 years of experience in doing that, because this was very novel. And so, by the time I was 24, 25, I could speak their language. I'd kind of grown up there. So I knew, and I think this is important for young people, I knew what I didn't know. So I sort of had a little bit of the humility of sort of understanding what they were much smarter than me at. So I knew when to shut up and listen, but I also knew when I knew the most in the room.
Yeah, right. You could speak with confidence, it sounds like, which I'm sure they appreciated.
At least sort of in the data science space as it pertains to investing. And so as a young person, I mean, there was a point where we were like, okay, maybe we should hire somebody with 10 years of experience in data science. But you would meet those people and they would be ready for a leadership role in their career and they would have a lot of confidence. But then, you ask them, what is EBITDA? And they wouldn't know.
Yeah,
and
right.
So it would be hard to do the job without some cross-disciplinary kind of point of view.
Yeah. It's interesting that you talk about this theme, because the 20th century was the century of specialization. And we did it to a fault, where people were in these, silos of knowledge and expertise. But that's not the way the world works. The world is full of systems that intersect with each other, and where data or forces are entangled, really. So I think you're making a really good point, and about this moment with data, business, and technology all meeting.
And by the way, the person I used to work for, the founder of Coatue, Philippe Lafont, he always tells this story that echoes the sentiment where, growing up, he went to MIT and he wanted a job at Apple Computer. Yeah. And he applied many times and was always rejected. And then he ended up, the way life took him, he ended up becoming an investor in technology. He invested in Apple. And Apple was, really a winning position for Coatue throughout the entire 2000s,
right,
and beyond. And so, sometimes, simply running at a wall is hard unless you're in the 0.1%. You're in the Olympic athlete category of that area. But you might very well possess a piece of knowledge that if you translate to a different area, you get a unique advantage. And sometimes some of the biggest scientific discoveries are made that way. By just, you see this in physics and mathematics a lot, where there's some theoretical idea in mathematics that ends up actually being really good for describing a physical phenomenon.
Right. It's right on the borderline. Yeah. Hey, you mentioned alternative data. Now, I want you to define it, but also my sense is that Coatue was really a pioneer in identifying the value of that on Wall Street. So tell us about that, alternative data.
Yeah. So I think, alternative data became a word before alternative facts were a word.
Oh,
so
great.
we were unfortunate enough to sort of, maybe alternative data needs a better branding expert. But the idea was in the early 2010s that Wall Street had been inundated with data for a long time. Businesses like S&P and Bloomberg and FactSet are 30 plus years old. So, there was no shortage of data on Wall Street. But almost all of that data referred to financial markets. So it was pricing data, volume of exchange traded data. It was company financials. It was, everything to do with legal filings that public companies file. And that was traditional financial data. And, the type of data that became known as alternative data was basically everything else. So it was kind of an alternative to the traditional financial data. And this everything else generally centered around how businesses and consumers were performing in the economy. So consumer spending data, business spending data, consumer behavioral data, anything and everything that could tell us, if you think of SimCity. Yeah. So when you play SimCity, you kind of have a 360-degree view of the world. Alternative data is that data that you see on the SimCity dashboards. It's effectively what is going on in the world, and then, what these hedge funds and the financial asset management industry has done is translate that data into investment decisions and tie it to traditional financial data.
Yeah. And SimCity, a lot of it's about mood. How do the artificial people in your artificial city feel about the way you're manipulating them, or what infrastructure you're giving them? And I guess mood has a lot to do with business, doesn't it?
Yeah, I mean, a lot of the premise of alternative data is it's a passive way of measuring behavior. Yeah. And, this is actually very interesting because traditionally the way in the 20th century, the cutting edge technology for this was surveys. Right. But as we know, people lie on surveys. People answer differently depending on their mood. People answer differently depending on how you answer the question. And so alternative data promised a more accurate, less biased form of survey taking because it's passive. So you're not asking people what they would do. You're just measuring what they actually do.
Right. Very good. Now, I want to introduce another term, and this is data as a service. That is the big idea underlying Cybersyn. So explain what that is, what's the business model, and what particular approach is your company bringing to the party?
Sure. So first, I will say data as a service is certainly not invented by Cybersyn. In some ways, these information services companies have been around for 100 years. When you look back at the history of FICO, for example. So we certainly didn't invent the model. Now, I think that alongside Snowflake, we have capitalized on a few new ideas in this concept of selling data that are novel, right? And Snowflake talks a lot about this concept of data cloud. And one concept or construct in that data cloud is data collaboration and data sharing. Mm-hmm. And so in some sense, this is new because traditionally the way data was sold was you would sort of send somebody a file and there'd be a discrete transaction. You would email them an Excel file or you would drop them an FTP. And maybe there was some schedule on which you would update that data. But that was kind of it. And Snowflake enabled kind of this continuous data sharing. So my data consumer sees the same thing that is in my Snowflake tables. So as I update my data, they instantly get those updates without doing anything, right? So in some sense, Cybersyn aims to capitalize on the Snowflake technology, which is new. And we're not the only ones, but the idea is to be the best shining example of what a modern data provider could look like. So that's the technology angle. And then there's the sort of data angle. And the data angle we're particularly focused on is what we call Consumer 360. And we have this underlying thesis that, look, there's a lot of data as a service companies that have picked a narrow niche or a narrow vertical And narrow could be, as wide as healthcare or as wide as CPG, but nonetheless narrow. And I've said, okay, we're going to be the provider of record for the number of people that watch TV or for the number of people that buy, certain products in the grocery store. And the hypothesis under Cybersyn is like, okay, great, but actually the underlying data that serves all these industries is the same. And that underlying data is just economic data. And we're starting with what consumers are spending money and time on. And our hypothesis is that if we stitch this data together, we could then market and sell it to a bunch of different industries. Mm-hmm. So we're not building a data provider for healthcare. We're not building a data provider for hedge funds. We're building a data provider for all of those things under the thesis that, if you could stitch together this consumer 360, you could serve all those industries at once. That's the hypothesis. And everybody's been saying consumer 360 for 20 years, maybe longer than I've been alive, but nobody's done it. And I think it's doable.
Yeah, no, I think that's great. Now, I've done a little bit of research on you. I know you love the movie Moneyball. And for others who may not remember it, 2011 is a great film, Brad Pitt in it, about how data analytics began to transform baseball. And you talk about the Moneyballization of business. What do you mean by that?
So what I really mean there is, so first, going back to the movie, and I encourage everybody to watch it if you haven't seen it, the basic premise, right, was that you could go into an industry that made decisions using just human judgment, and you could apply structure and rigor, and that structure can be often analytical or quantitative structure. So you could actually measure data and then make decisions objectively, right? And the idea is that if you pair domain knowledge with this objective rigor, you get something better than if you just relied on domain knowledge. I didn't particularly care about baseball. I'm a hockey fan, but the concept really turned me on to data science. And that concept can be transplanted not just to hockey, where my first kind of interest in transplanting it was, but it could be translated to any place where people make decisions, policy decisions, business decisions, investing decisions, using that same sort of rigor. If the data is first collected and available, and then analyzed correctly. And by the way, for those that have heard me say this before around Moneyball, there's a great new book out by a counterpart at Point72, Joe Peta, around sort of the direct translation from Moneyball to investing. He works for Point72 and is involved with the Mets. So he has a unique vantage point of directly being involved with a baseball team and with investing. Right. So I highly recommend it.
Yeah, it's interesting. Now, I've watched parts of Moneyball recently just to kind of refresh my memory of it. And it's interesting because baseball is a place where, those coaches, it's gut instinct. Now, it's based on domain knowledge, but so many of their decisions were these gut instinct decisions. But people don't realize that in business, in other businesses, it's a lot the same. There are a lot of people who make gut, decisions about investment or about strategy and things like that. And it seems to me that is one of the great weaknesses of kind of late 20th century business world. Do you feel like this combination of domain knowledge and objective rigor is really starting to be applied in kind of on a mass scale?
Well, I think we're starting to see it. So I think that the last 10 years have seen kind of more and more organizations build data science teams internally, right? So you'd be hard pressed to name a Fortune 500 firm that doesn't have somebody with the title data scientist at that firm. And that wasn't true 10 years ago. Right. So I think there's been a transformation for internal data science teams. And I think now the second step as it relates to Cybersyn is external data teams. So consuming external data, this is kind of part of the so-called data cloud. The idea of the data cloud being that, look, let's say you're an amazing data science organization, you're Netflix, right? No doubt one of the top tier firms that using data to drive decisions. So let's take one problem, movie recommendation. So they look at your browsing history, they have a complex algorithm and decide what to recommend to you that you would like to watch next. Now the question is, if you want to improve that recommendation, you could hire 20 more PhDs and have them optimize the algorithm by 0.5%. But I would bet you would have more return on your investment if you instead found a data set that told you what your consumers were watching on Hulu or Disney Plus, and you simply added those features, those external data sets, that competitive intelligence to your model. And so my sense is that the world has woken up to the need to use data internally. And we are, way past the early adopter stage of that. But we are now at the beginning of adopting and using external data. And, that's not to say people, there is an external data business. I mean, again, a lot of these large data companies have been around for a long time, but I think they've been underappreciated. And I think that they're in some ways, this will be a big next step. And Snowflake has enabled that, right? Where, if everybody puts their data in the same cloud, suddenly collaborating and sharing becomes very valuable. And unless you're Google, you only have, even if you're the largest, company in terms of sales, you probably only have 1% of the data that you could have to make economic decisions.
Yeah. No, I agree with you 100%. I mean, I think that systems thinking, or also sometimes called complexity theory, this was one of the great cognitive inventions of the late 20th century. And I think it's only now really coming into practice. And I think it's the data cloud, it's this data sharing, and it's the kind of thing that you're doing that really make it feasible.
You mentioned one thing earlier, around sort of gut instinct and sort of domain knowledge. I'm not a data absolutist. I think that there actually are, and if you there's really interesting research. Phil Tetlock at Penn and Michael Mabusson have some really interesting research around so-called super forecasters. And I think there's a really, really interesting opportunity to quantify and measure those super forecasters. So if somebody says, look, I don't need data. I've seen enough of this. I have the internal pattern recognition to do this. That may be true. But in that case, we should measure it. And if we can measure it and quantify it, we could transplant that knowledge to people that aren't experts, right? And that itself could have a lot of business value. So if somebody is just an amazing medical doctor and they see a patient and they can diagnose just based on gut feeling, just like, oh, it must be this disease. If we can quantify what inputs are going into that decision and how we arrive at an output, right, and measure the accuracy, then suddenly we can make that expert medical knowledge, that 0.1% of medical performance available to other doctors.
Yeah, that's interesting because a doctor who can do that, it really isn't gut instinct. It's their processing a lot of stuff invisibly to the rest of us and coming up with a more accurate prediction of what's really happening. So that's really interesting.
Exactly.
Now, Now, I want to go back to Coatue a little bit. Again, I don't want to get too bogged down, but you learned about Snowflake when you were at Coatue. So tell us how that happened. What did the data cloud, the marketplace, the data sharing, whatever the values or that were so valuable to Coatue, what were they? And how did Coatue use them? And what did it do for Coatue, that it couldn't do as well previously?
So look, when we built the data science team at Coatue, and we were just starting with alternative data, we were getting these large data sets, and we needed to be able to ad hoc query them. We were doing a very large amount of what I call exploratory data analysis. So we had to check, is this data set going to be useful in modeling the revenue of this public company? Or is this data set going to be useful in predicting inflation? So there's a lot of EDA. And this EDA, we would try a lot of things and you would often fail. And so you needed some system by which you could sort of iterate very quickly because you didn't want to be waiting for results, right? Like you wanted results in seconds, not minutes or hours, because the more things you could try, the more likely you'd find something that would work. And you wanted to centralize your data. We recognized that Snowflake had separated storage and compute. And we could sort of add as much data as we wanted and then spin up compute when we needed it and spin it down when we didn't. And those two were independent of each other. And that was initially what grabbed our attention. And so we ran a POC, sort of saw that we could get more compute and compute things faster when we needed to, but actually spend less total cost because we could spin those resources down when we didn't need to. So that was the initial solve, right? Like that was when we first implemented Snowflake, like that's all we were going for. And that was huge.
Yeah.
So that was step one. And then step two, the second big part of the value was the data sharing components. And, Snowflake had first launched data sharing and then ultimately Marketplace. We were buying data sets from many, many, many different sources. And for every data set we bought, we probably tested like 3, right? And so we had an entire team dedicated to just ingesting or loading data, right? And that consisted of sort of defining, understanding where the data landed, whether that was a, blob storage, whether that was an FTP, whether that was an API or whatever it was, and then writing logic against that to load the data. And then if it went into production, to kind of repeat that logic, detect when something changed and reload it, right? And so when Snowflake came out with data sharing, we felt like we could save ourselves a massive amount of just engineering time for every vendor that adopted data sharing because it was basically no work. That ETL was sort of already done. And it made all the sense in the world if the data provider was on Snowflake themselves too. Because what they were doing previously was basically egressing the data, putting it in S3 bucket or FTP or whatever, and then we were ingressing it into Snowflake. And so we were all paying compute cost, we were all paying network transfer fees, like for no reason, right? That data was making essentially a round trip.
Right.
And so that was massive in unlocking our ability to test and run sort of data sets faster. In that industry, the more data sets you could test, the quicker you come to the data sets that actually make a difference in your ultimate P&L. And so, increasing the speed of data ingestion and data trials ultimately leads to sort of a lot of value kind of down the road.
Okay.
And then look, at the end of the day, Coatue is in a decision-making business, right? Ultimately, they get paid for making decisions. Right. So the ability to have a centralized source of data, which Snowflake was for Coatue, where all of that data could be joined together and ultimately exposed to the decision makers, that makes all the difference.
Yeah, that's great. I want to get back to Cybersyn. Now, your business basically lives in the Snowflake data cloud.
Correct.
So tell us how you use the marketplace, the sharing capabilities to acquire, combine and sell data sets. In particular, I'm interested in learning about your economic data sets and the ones you're creating for particular industries. Now, you talked before about how you don't kind of create slivers or for different domains, but you kind of package it that way, right?
Yeah. So let's talk about it. So, I think first of all, on the Snowflake usage, so we effectively dog food the Snowflake product in everything we do. Right. So ideally, when we acquire data, it's already in Snowflake and can simply be shared to us. Yes. And in other cases, we have to fetch it from somewhere, right? And it could be from a public data source. It could be from a private proprietary data source and push it into Snowflake. From there, we really run all of our compute in Snowflake. Mm-hmm. So we, all of our transformations are done in dbt, and we use Snowpark and just SQL, Snowflake flavored SQL, to do all the transformations. Mm-hmm. We then, ultimately publish our finalized derived data sets in the Snowflake marketplace. Right. And our clients and customers are consuming it from that shared database that they mount via the marketplace or via private listing. Yeah. The other thing, that's really interesting is we make very heavy use of Streamlit, which is relatively recent Snowflake acquisition. And Streamlit is really this amazing tool. You could call it many different things. I see it as kind of an evolution of business intelligence, right? Of BI tools, in that it allows you to very quickly and in almost declarative fashion create dashboards and tools that sort of let you demonstrate data. Often the buyer of data is not the frontline user of data. And so it's very important to demo what is possible with the data and to visualize it in a way that's compelling and also potentially useful. We're not in the business of building vertical SaaS applications, right, but we do want to be able to allow all types of users to explore our data as they sort of look for what they need. And so Streamlit and Streamlit on native applications plays a very big role in that.
So those dashboards are kind of industry or domain use cases?
They're either industry or domain use cases. So, you can imagine we sort of take a data set and you can think of the Streamlit as a starter kit for a given industry. Right. So we use the data to build something that somebody in a particular industry could use as a jumping off point. So our most popular free Streamlit has been our financial data, our financial essentials app. And that's available both as a standalone Streamlit, as a Snowflake native application. And of course, you can just mount the underlying data as well. And, that serves as a jumping off point. When the sort of all the news around the FDIC and Silicon Valley Bank happened earlier this year, right. We had a lot of clients sort of asking us, Snowflake clients that is, asking us about FDIC data. And so we, created a listing that, among other things, included the FDIC data. But we really wanted to go a step further and say, okay, not only do we want to provide this data, but we want to visualize sort of what it would look like and sort of illustrate the most common analyses that people were probably doing. In this case, sort of what percentage of a bank's assets were insured by the FDIC. And so the Streamlets and the apps kind of served as a starter kit, if you will, for folks.
Yeah, no, that makes total sense. Now, you've been talking about kind of dashboards, Streamlit apps, things like that. But I understand that your latest initiative is selling data applications in the marketplace, starting with financial and economic essentials is the name of one of them. E-commerce benchmarks is another. These are like fully developed applications. Do they have data sets that kind of come with them as a package, library, or something like that? Or how does that work?
Exactly. I mean, it's not too different. Effectively what native applications are, and the way I think about native applications is that it's a way to share both data and code with consumers in a secure way. Mm-hmm. And so we can basically share both the Streamlit application itself, which runs natively in Snowflake. Right. So the end consumer can choose how to provision it, how to govern it, how much resources to give that Streamlit application to ultimately issue queries against data. Oh, and by the way, you can just query that data directly. You could replicate the queries the Streamlit app is issuing and sort of dig into it. So we see native applications as really a package of sort of both compute and data that then comes with additional benefits like versioning that data alone can't give you. Yeah. So if data sharing is kind of step one, then sort of sharing applications on Snowflake is sort of step two. Yeah. But our goal with native applications, at least in the confines of Cybersyn, certainly other providers could do this, is not to build the best vertical software for healthcare and the best vertical software for MarTech or anything like that. Our goal with the native applications is actually to have a more intelligent way of sharing data. It's just that when you share data, you also often want to share common functions, common dashboards, common features, and native applications is the conduit.
Mm-hmm. Now, starting with back when you were with Coatue, I mean, Coatue was one of the early users, aggressive users of Marketplace. So you've kind of seen the evolution of this platform. And it's funny, I haven't really tuned in recently to what's going on there. So could you give an update? Like what are like the newest, latest, most interesting things that you see happening there?
So, let me start with the tactical and then I'll get into the strategic. So on the tactical side, I think the biggest advances have been all of the data monetization features Snowflake Marketplace has rolled out. And that really allows you to complete an entire transaction within Snowflake, right? And, depending on the data set, you can pay for that data based on rows consumed, based on queries ran, or just based on time, right?
And all that monitoring is built right into the system, right?
All of that monitoring is built into the system.
Very cool.
And then additionally, as of Snowflake Summit, there is a market capacity drawdown program, which basically means that you could use a portion of your Snowflake credits to pay for data, right? And so that means that everything is done effectively on Snowflake's paper, which, massively eases the procurement process because you are spending Snowflake credits on data sets that you need as opposed to exclusively on compute. And so it's just another way to make use of your Snowflake credits. And obviously as a data provider, it's fantastic because it sort of makes it easier to transact.
Yeah. Yeah. Hey, it's funny. We're pretty deep into our podcast, into our list of questions here, and I can't believe it, but I haven't asked you about large language models yet.
Yeah.
What's
That's rare
wrong?
these days.
What's wrong here? But I'm acutely aware. I mean, I was actually in the middle of writing a book about data with Bob Buglia, former Microsoft and Snowflake executive, when along came large language models, and he was talking about them. He was actually calling them foundation models. And then boom, this thing happened and the world just went nuts. And, this is, we're in full hype now. So what role do large language models play in your technology and in your offerings?
Yeah, it's a great question. So I think that I see three ways large language models play into the Cybersyn story. So first, they can be a very useful tool to clean and join and structure data. So we can use them internally to make more data sets available that maybe weren't available before, or make data sets joinable in a way they were before. So I think that's one aspect. A second aspect is large language models have fueled a demand for properly licensed, compliant data that can be used to fine-tune or train models. And yes, everybody uses, the common crawl corpus or the pile corpus, but there's a lot of additional public domain data sets that could be compliantly used, such as US government contracts, patents, SEC filings that we make available on the Snowflake marketplace that serve as really good inputs and effectively are compliant inputs into a large language model, which for enterprise use cases is very important. In the future, we also hope to offer sort of proprietary inputs that are properly licensed and sort of provide the right amount of protection that could be used into a language model. So it's sort of like we could use it internally. A lot of our customers use our data for their own fine tuning, and sort of we support enterprise use cases because we pay a lot of attention to data rights. And then, I think the third thing is large language models will democratize access to data. And Frank and Jensen talked about this, where more and more people will sort of be able to chat with their data, so to speak. And they talked about this at Summit. And so that will just increase the audience for external data sets. And I think that's the third leg of the stool for Cybersyn on how large language models sort of play into it. Yeah. I think the other thing I have to say about large language models, AI and LLMs, that maybe is sort of non-consensus, or at least has been talked about less, is around sort of the role of structured data in large language models. So I think it's very clear large language models have suddenly allowed unstructured data to be accessed. And Snowflake has a series of tools that allow you to now process unstructured data and run large language models on them. But I would also point out, it's not as if structured data is dead. Some of the most valuable data sets in any organization are structured, right? Like ultimately sales information,
yes,
right? Customer data is by and large structured data, right? Now, where I think large language models apply is that they allow us to take that structured data and join it to things that before would be very difficult to do. So I think in some ways, large language models might transform structured data before we solve all of the generative and unstructured data use cases that have problems with hallucination and so on. Yeah. So just to give a very concrete example, one very common task in structured data is entity resolution or fuzzy joining. Right. So basically, I have a table of companies and these are the prospects, and then I have a table of my customers and the name of the company is similar but not exactly the same, and I want to join them. So, say I have Walmart Inc. and then I have Walmart's, or I have Snowflake Computing Inc. and then I have Snowflake Inc. And obviously a human can know that these two things are actually referring to the same entity, but it's not always obvious. Right. And traditional methods for fuzzy joining that would use, just character similarity might not capture the differences, right? Snowflake LLC and Snowflake Inc. are far less likely to be the same entity than Snowflake Computing Inc. and Snowflake Inc., right? And so a human knows that an LLC is a very different type of entity than a corporation. And so there could be some fungibility in how a corporation could be spelled, but the corporation is like a separate concept from the LLC, which might just be somebody's LLC somewhere.
Right.
And so with embeddings, suddenly the ability to join these concepts and to run joins that are semantically aware seems much more feasible. And I think it's a really interesting area that maybe hasn't received the sort of love it deserves.
I see the future.
What a fascinating modern age we live in.
Is this what the future holds?
Now, I wanted to ask you kind of to put on your visionary cap. I mean, you've done an incredibly good job of kind of explaining where we are, but I want you to look out into the future. So looking out like 5 years or more, how do you see data analytics transforming business and even society?
Yeah, it's a great big question. So I think that there's a few areas that I hope and I think will change. So I think one area in general is this like democratization of data access. So Snowflake becomes a tool not just for the data engineer or the data scientist, but becomes a tool for the decision maker and the business analyst. I think that's, clearly a trend, right? Where, and I think large language models will help, but I think a lot of other technology will help as well, having more people be able to access and interact with data. So I think that's, one whole area is more people will use data sort of in their job because it's suddenly accessible to them. And we don't all need to be SQL experts, right? I think there will be room for SQL experts, but I think that in general, it will be available in more ways. And, Streamlit is a great example of kind of that next generation of ways to interact with large language models or with data sets. So I think that's kind of one area, like human-computer interaction. I think a second area that will be transformed is, and this is like a little bit more philosophical, is I think that this ethos of making Moneyballized decisions will permeate sort of more and more of business and political life. And so, we'll have better and real-time information on everything, including our economy. And hopefully the folks making decisions at the highest levels, so think the Federal Reserve, will be making those life-altering, economy-altering decisions based on sort of real-time data, as opposed to relying on surveys. And so I think, and I've been sort of watching and in touch with organizations such as the U.S. Census Bureau, as they started to launch innovation projects to better track things like the supply chain and like the economy in closer to real time in more granular ways that are still privacy respecting. Yeah. And so I think that as those initiatives take off, suddenly all the decision making in policy making will itself be very data driven. And therefore more transparent and hopefully more accurate.
For your information, there's a lot more to ogres than people think.
Really need to dig deep and get to know the real you.
In them real up close and personal.
We're coming to the end of our podcast, and we typically end on a more personal note or a lighter note. And I understand that you were a strategy game nut when you were a kid, like SimCity and Age of Empires. And this was like this is when you were a preteen, so you were a prodigy at this stuff. So how did that passion emerge in a preteen, and how did it lay the groundwork for what you do now?
Yeah, it's a great question. I mean, I think I'm not unique at all in liking video games. I think, in some ways, like it just so happened I became interested in video games where you build things. And, I sort of I think that there's video games that test your reflexes, reaction time, and so on. And there's video games that basically allow you to thoughtfully plan ahead. And that was always more appealing to me, maybe, nature versus nurture. And so that led me down this path of Age of Empires and SimCity and StarCraft and so on. And, in some ways, I enjoyed those games so much, I secretly hoped that there were jobs in the real world that would be the equivalent of simply playing those games. I mean, and I've repeated this anecdote, but, it's sort of like when you play SimCity when you're 12, your conception of what a mayor does is sort of play SimCity. And, then you learn disappointingly that that's not true. But why couldn't it be true? In some ways, having a 360 view of your populace and how your decisions actually impact your city would be very helpful.
Yeah. Yeah. It's interesting. In my city, New Haven, and in other cities in Connecticut, we have an organization. It's called Data Haven. Basically, they collect that data. They collect the alternative data for the city and about the people, the condition of the people, the condition of their life conditions, all that kind of stuff. So our mayor does have that information. So hopefully making good decisions.
Yeah.
Their bigger problem usually is money.
Right.
Not understanding what the problems are. It's getting the money to solve them.
Well, it's part of, and this is part of the reason why, some things, such as I think building a data, solving this data challenge, you do it as a commercial entity to make it sort of self-sustaining. But I think there's also a lot of very interesting nonprofit work going on. I mean, Raj Chetty at Harvard and his Opportunity Insights project, which focuses on measuring income mobility in the United States, I think is a great example of using this sort of alternative data in a similar way, trying to get a real-time sense of what does income mobility in the US look like.
Yeah, that's good. That's good. I'll have to look that up. Well, this has been a great conversation. I love your energy and enthusiasm, and I really think you are in a pioneer spot. I mean, I think you're right that this integrating external data into the formula for figuring out what the heck is going on around us is critically important, and we're just at the beginning of it. And I think our podcast listeners are really going to get a lot out of this one. So thank you so much for being with us.
Thank you for having me. This was fantastic.
How you approach data will define what's possible for your organization. Data engineers, data scientists, application developers, and a host of other data professionals who depend on the Snowflake data cloud continue to thrive thanks to a decade of technology breakthroughs. But that journey is only the beginning. Catch up on all the latest announcements from Snowflake Summit, including advancements with generative AI and LLMs, flexible programmability, application development, and much more. Watch now at snowflake.com/summit/livestream.